Next, let's define the simulation mask. As TechWiz solver performs the calculation based on the simulation mask area, designing the simulation mask considering the boundary condition is very significant. There are two types of boundary conditions, periodic and Newman. When calculation area is periodically repeated and x and y axes of the boundary conditions are the same, periodic is used. So when cells are repeated like this figure, please select periodic. On the other hand, Newman means that the slope at the boundary is 0. For example, when electrodes or insulators are continuously arranged outside the simulation area, Newman is selected. In this example, I drew the periodic type, so we will use the periodic boundary condition. And let's define the stack information. At first, click the simulation area and then click this button. Layers can be defined by drag and drop in the DB list. Just add materials in the stack list in the order of the actual process recipe. So in this example, based on this figure, let's define the stack list. First, drag and drop the material of all layers to be used. I will define it from the top to the bottom. If you use the same material, just copy and paste it. Ctrl C and Ctrl V. Also, I will copy and paste it. This one too. Also, you can modify the layer name. Click this one. This one is a glass BM, and I have to change this one as common. So I want to change this one as pixel. In order to define the properties of each layer in detail, I will explain the properties first. The first property is a layer. You can set the name and the thickness of the layers. Additionally, it is possible to set the material type of the layers. If the layer is stacked, select stack. If the layer is a substrate, select substrate. If the material is being filled like LC, select fill. In other words, you can select the top and bottom substrates as substrates, LC as fill, and other layers as stack. Please note that the property items are totally different depending on the substrate type. So, define the exact substrate type is very important. And division means the number of divisions. Planarize is mainly used in dielectrics, and you can set the degree of planarization called DOP and choose between no and yes. If you select no, the planarization option is not applied and a conformer structure is generated like this. If you select yes, planarization option is applied. Also, you can set the DOP from 0 to 1. When the value is close to 1, the structure will be perfectly planarized. On the other hand, when the value is 0, it is the same as selecting no, which has the conformer surface. Finally, the edge stopper. This function works with unselective edge. If unselective edge is set to yes, the etching process starts from that layer. Then, etching proceeds until just for the layer for which the edge stopper is yes. This is because an edge stopper literally means to stop the etch process. Let's understand clearly by looking at an examples. So, for layer 3, unselective etch is set to yes. Therefore, the etching process starts from layer 3, like this. And look at the second example. For layer 3, unselective etch is set to yes, and layer 0 is an etch stopper. In this case, etching process is performed from layer 3 to layer 1 because layer 0 is an etch stopper. There are several notes for using these options. The purpose of the layer that you want to use the unselective etch function should be set to contact in the tech file. And substrate, metal, LC layers are automatically set as etch stoppers. Reflow function is used when you want to generate more realistic 3D structure. Comparing the structures from the side, the difference can be clearly identified. And then in the patterning property, define the mask for the layer. Select the particular mask and mask type. Choose the sidewall model among 7 taper models. When a specific taper model is selected, the taper type and taper value are activated. There are 2 types, taper angle and taper width. If you select taper angle, you can input the angle. And if you select taper width, you can enter the width. Also, CD margin can be set. The plus value means under etching and minus means over etching. There is a rounding option. This rounding option is the same as I mentioned before in the layout, so I will skip it. And if you input the displacement to move a mask in the shift X and Y, the mask is moved by that distance. Also, generating the over-etch structures can be possible by using the over-etch thickness option. Let's check an example. Insulator 2 is positioned on the insulator 1, and insulator 1 is over-etching by the shape of the insulator 2. At this time, enter the over edge thickness for the insulator 2 and set the edge stopper no for the insulator 1. Look at this example. The thickness of the insulator 2 is 1.5 micrometers and the thickness of the insulator 1 is 1 micrometer. And the over edge thickness is 1.3 micrometers. So, the over edge thickness of 1.3 micrometers can be expressed as follows. Lastly, change material property. You can change specific areas of a layer with different materials. First, select whether to use the function in change material and enter the number of materials to change in the count field. And material and filter are displayed as many as the number entered. In the material, select the material to be changed. And in the filter, set which area the material is to be changed. And means the intersection. For example, the intersection of A and B is this part, and the intersection of A, B, and C is this area. In the same way, not means the difference. Therefore, the difference between A and B is this part, and the difference between A, B, and C is this region where the material changes. So, we have talked about all of the properties. From now on, let's go back to the program and define the property of the layers. So first of all, there is a glass substrate at the bottom. The substrate should be selected as substrate. In general, in the case of FFS, IPS, and PVA modes, the electric field effects at the boundary of the substrate should be considered. So, usually the thickness of the top glass is about 30 micrometers, and for the bottom glass, 10 micrometers. However, in this example, let's use 1 micrometer for quick calculations. And division means that the number of divisions. For substrates like glass, the solver automatically divides the layer, so I will skip it. And the next one is gate. This is tech, and the thickness should be 0.4 micrometers. And I designed the gate mask, so I will choose it. And then I will use the default values for other items. The next one is gate insulator. The thickness is 0.4. And then the next one is data. The thickness is 0.3. And let's choose the data for the mask. And the next one is passive layer. The thickness is 0.3. And this is a Viahor mask. Next one is pixel. The thickness is 0.05. This is a pixel mask. And for the PI layer, the thickness is 0.08. And then also I will use the default values for other layers. And the next one is LC. The LC layer needs to change the substrate to fill, but automatically it is changed. And then at this time the thickness means the cell gap of the LC, and it is changed to 3.5 micrometers. And then for the division, I'd like to recommend that you enter the value as 21, but today, to check the result very quickly, let's enter 10. And from now on, let's define the structure above. As it is a top glass substrate, it is changed to substrate. And then the thickness is 1 micrometer. So let's move on to the next layer, PM. The thickness is 0.5 micrometer. And then particularly, please check twice the mask type of the PM. In this example, we designed the positive PM mask. So let's move on. Thickness should be 1 micrometer. And let's use the planarization option. Set planarize set to yes, and DOP value to 1. Also, the next one is common electrode. The thickness is 0.05. And the next one is top PI layer. The thickness is 0.08. So we define the properties of all layers. Next, click mesh condition, which sets the conditions for mesh generation. To generate a 3D structure and identify the properties of the structure, mesh generation is very essential. TechWiz LCD uses a tetrahedral mesh where the length of one side is the unit length. Therefore, the smaller the unit length, the tighter the mesh is generated. So, an accurate solution can be obtained. However, it has the disadvantage of taking a long time to calculate. On the other hand, if the unit length is large, the calculation time is very fast, but the accuracy is lowered. Therefore, proper unit length setting is required. Generally, in TFT LCD mode, about 0.5 to 1 micrometer is used. But in this training, I will use 3 micrometers for quick calculations. And the next one is refinement. If you click yes, max length, gamma levels are activated. So by entering these values, refinement allows you to decrease the density of entire mesh and increase the accuracy of calculations. However, it is an advanced option, so I only recommend it for the professionals. And the next one is boundary condition. You can set the boundary conditions for the X and Y axis. There are periodic and Newman conditions, but we already designed the periodic simulation mask, so let's select periodic. The next one is gap position. It means that the reference X and Y coordinates, which define the thickness of all layers including LC layer. Please note that there should be the gap position coordinates inside the simulation mask. So in this example, let's enter 30, 30 respectively. And in STL out and STL scale factor, you can select whether to output a surface mesh in STL format. Therefore, generated 3D structure by TechWiz program can be utilized by other commercial tools. And in touch condition, there are various functions for TSP simulation, bending simulation, and setting the advanced mesh conditions. In this time, I will skip it. If you are interested in this part, please refer to the manual. So far, I have defined the stack list and mesh conditions. Please save this file. This file is saved as a SDF file, and then you can easily load it later by clicking this Open button. And now the next step is to choose whether to generate a mesh only or generate a mesh and a project file. If you select Generate Only Mesh button, only the mesh file is generated. If you select Generate with project file that can be used in TechWiz LCD 3D and a mesh file are saved in the folder. In this training, please click Generate with project. And then in the log file, a message appeared. And you can see that the mesh file was created. If so, now let's check the mesh file through preview and check